Hello everyone, welcome back to the channel. I hope you all are doing well. Today we will be tackling a challenging problem from Kicks for Kicks, and it is categorized as a medium level problem. So let's dive into the problem statement. The problem name is Palindrome linked list. So given a single linked list of integers, the task is to check if the given linked list is palindrome or not. So there are some examples. You are supposed to given a linked list like 1 2 1 1 2 1, and you can say that the output will be true if the given linked list is palindrome. You all know what is called palindrome, like madam. Madam, why madam is palindrome? Because the first element is matching with the last element. The second element will match with the second last element of the string. So like that, madam is a palindrome, and mom is a palindrome. So these examples are of palindrome. So here is another example, 1 2 3 4, and this is not palindrome because 1 will mismatch with 4, and it is palindrome because 1 with match with 1, 2 with match with 2, 1 with 1 is match with 1. So let's go to the pen and paper where I will make you a clear understand of this solution. So this is the given linked list, and I have to in output I have to return true. In output I have to return true or false. If the linked list is palindrome, then I will return true, else I will return false. So one thing you can say that you can just iterate through the linked list and store all the values, all the data of each and every node in a data structure, and after it I will traverse that data structure and I will say that if that data structure is palindrome, then we can simply return it as true or false. So how we can approach it? We can store each and every element into a stack like 1 2 3 2 1, and as we know stack is last in first out, so it will check from these element and which is the last element of my linked list. So it will compare the last with the first, and I will pop out from the stack, and then I will go to the temp next and it will check with these two and pop out from my stack, and next temp will be temp next, and next I will pop out from my stack, 3 will pop out from the stack. Like this I can solve this problem, but the main catch is I cannot use any extra space here, because in my question they have said that we have to do the solution in big of 1 time complexity. So here we cannot use any space. So what I will do, I can do one thing, that you can see here, just if you reverse this linked list and compare with the first half, then you can say you can check it easily. But the catch is here, you have to reverse the linked list, you have to reverse this part only, you cannot reverse the whole linked list. Another example I will take is 1 2 3 3 2 1. So the difference between these two linked list is the size, okay, and here you can see that the size of the linked list is odd, and here is the linked list, the size of the linked list is even. So you can reverse, if you reverse this part only and check, after reversing the linked list will become 1 2 3, and if you check one suppose one pointer is here, first pointer, and another is second pointer. If I point these two index point these two nodes where after reversing here and before, and the head of the linked list is here. If I iterate these two linked list, then I can simply get the output that if my linked list is palindrome or not. So I have to reverse this part and I have to compare between these two parts. Same here, I can reverse this part only because we all know that this is a center element. So we suppose if I give you an example of madam, so M will compare with M, A will compare with A, but as D is a middle element, I don't have to compare with D. I don't have to compare D with any other element. Same here, I don't have to compare 3 with any other element. So I just can reverse this part only 1, 2, and my linked list will become 1 and once next is 2. So I can simply compare this part and this part. Clear? So how I will do it? So for solving it, I have to find out the middle element of my linked list. So sorry, I have forgotten to start recording. So I can say that to reverse this part only and reverse this part only, I have to find out the middle of the linked list. Here I can see that this 3 node is the middle of my linked list, and same here I can say that this 2 element is the middle of my linked list, but I will take this node only. Okay, so now question is how I can get the middle element of the linked list. So you have to keep in your mind that if you have to find the middle element of your linked list, or you have to find the length of the linked list, so instead of iterating throughout the linked list, the whole linked list, you can use slow and fast pointer concept. Okay, so keep in mind, it is very important when you have to use slow and fast pointer in linked list. So suppose I will give you an example first. Suppose my name is X and my friend's name is Y, and my speed is 2s and my friend's speed is s. So suppose this is the total distance from source to destination. This is the total distance, and we both have started from this starting point. Okay, and suppose as x speed is twice of y, so suppose x reached here, x is here now. Okay, x is here now. So as you can see that x's speed is twice of y, so you can say that y is the halfway of x. When x reaches the destination, so y will be the halfway of the total distance. So simply think about the speed, distance and time concept. So I can hope that you understood the concept, why I am telling it. So in the same way, you can use slow and fast pointer. Your slow pointer speed is s and your fast pointer speed is 2s, which means your fast pointer will move twice faster than your slow pointer. So suppose in this example 1, 2, 3, 2 and 1. So my slow pointer also starts from 1 and also my fast pointer also starts from 1. So I have said that my fast pointer speed is 2x of slow pointer. So when my fast pointer will move, my fast pointer in the fast move, fast pointer will go to 3. Why? Because it will jump 2 steps, and my slow pointer will jump to 2 as it will iterate through one step. Now my fast pointer is here and now my slow pointer is here, and you can say that if my and after that if I do fast next, then it will be out of the bound, so I will stop here. And you can say that my slow pointer is here and it is the middle of my linked list. Okay, hope it is clear. So I will return this slow pointer and it is the middle of the linked list. And if I reverse the slow next, then you can simply get 1 2, which is the reverse linked list. Okay, which is the reverse linked list of this part. But you have to keep it in mind, this 3 is not pointing this 1, this 3 is pointing to this 2. Okay, and this 1 will pointing to null. Okay, hope it is clear. I just reverse the pointer, like 1 is pointing to 2 and 2 and 3 is next is pointing to 2. Okay, so I have to, by reversing, I have to return the head, suppose this is the new head of my reversed part. Okay, and after getting the new head of the reverse part, I will compare between these two. Okay, I will compare between these two. So now coming to the coding part, where I will make you understand how I will solve this problem. So for slow and fast pointer, what I can do, suppose my function name is true or false bool function, you are supposed to give monster head. Okay, so I have already said that my fast and slow pointer will start from the very beginning of my linked list. So I will point my fast pointer as head, as well as I will point my slow pointer as head. Hope it is clear. And I will iterate through the linked list and I will move the fast and slow pointer. So one thing you have to check, when my while loop will terminate. Okay, so in this case you can see my fast pointer comes here, but what will be the scenario in this case when my size of the linked list is even? So now my fast pointer is here and my slow pointer points here. Okay, my slow pointer moves one path and my fast pointer will move two paths. My fast is here now, slow is here now. Slow will point these 3, fast will point these 3. So now you can see that I have to return this slow. Why this slow? Because this is, in this case, this is the middle of my linked list. And why I am doing this? Because I have to, in this case, I will reverse the slow next. Okay, the slow next, because my slow next is 2 1 and I will reverse this part only. And in this case my slow is here, I will reverse the slow next. I have to reverse this total part 3 2 1 slow next, reverse of slow next. Okay, so what will be the condition of the termination of the while loop? So if I see that now my fast pointer is here, and if I move the fast pointer will move as fast equals to fast next, means it will skip it and it will move further. And see here, when if the first pointer move further, then it will go out of bound. So I will check if while first of next, here first of next is null pointer, or first of next and next is null pointer or not. So I will check the both condition as for the even size and the odd size. So hope you have understood this concept, why I am taking in the while loop first next as well as first next next, which means while loop will iterate till till my first next is not null and first next next is not null. Okay, hope it is clear. And I will move first as first next next, and I will iterate as slow next. Now my slow is the middle element of my linked list, so I will do reversal and get the suppose my reverse linked list of slow next. I have already told you my slow is here and I will reverse this part slow, so I will reverse linked list of slow next. Same in the same way, my slow is here and I will reverse this part only, so I will do reverse linked list of slow next. Okay, and it will return the head of the, like this is not actually head, but I have to point these element only after reversing these element only 1 2. Same here 1 2 3 I have to return slow next and slow next will point out these only. Okay, so my after reversal node start temp will point out these only. Okay, node start temp will point out these. Same way node start temp will point these one. Okay, hope it is clear. Now what I will do, I have already said that another pointer will point here, and same way another pointer will point here, and one pointer will point here, and I will iterate the both linked list. So for that reason what I will do, node star first is equals to head as well as node star second is equals to, I have already said that temp will return the reversed head. Okay, 1, so it will return temp, node star s will become temp. Okay, now what will be my termination condition of my while loop? So there will be two termination condition. One is my second pointer will iterate until it becomes get any null, and the second condition will become my first pointer will move till I get any slow pointer. Okay, in this case, if this is because in the size can be differ, so I will not recommend this first pointer to check a condition of first pointer, because in this first pointer I have to check till now before the slow pointer, and in case of even my first pointer will have to check this slow only, and in case of even I have to before the slow. So I will check the second condition while my second pointer not equals to null, then I will check each and every data. I will compare this like this. I will check if data not equals to s dot data, I will simply return false. I will not check further. Okay, if it is not, if my while loop continues and while loop breaks after not getting any false, then I will simply return true. Okay, hope I am able to make you a clear understand of this problem. Now coming to the point where I will reverse my linked list. Okay, so how will you reverse a singly linked list? So suppose this is your example, and now we have to reverse it. Okay, so you can say that this next will point to null, and what I have to do, I have to just alter the pointer, and now this will be my new linked list 4 3 2 1, and it will pointing to null. So this is the concept, how I will reverse my linked list. So now getting to the main point, same way you can simply use a stack and you can simply reverse the linked list. So here also you have to use one extra space, which will be my space complexity will become my big of n, but I don't want any extra space, so I will think something else. What I will do, suppose you have these 3 element. Okay, don't think about the data of the element, you have these 3 node. Okay, and you have to reverse it. So how will you reverse? You will, when you are here, suppose you are in this node, when you are here, you can say that it's these nodes next will this, and you will move this pointer to here, and same way you will do this, these nodes next will be this, so this way you will do it. So for this you can see that you need 3 nodes. One node is a middle node, one is a previous node, and one is the next node. So I can say that this is my front node, this is my back node, and this is my temp node. Okay, so I need these 3 nodes to reverse the linked list, and I have to store this front, because if you move the arrow to the back, then you cannot go to the front anymore, because this link will be destroyed. So you have to store this front also. Suppose you are here, so what you will do, you will store the front. How you will store the front? Suppose node star front is equals to temp next. By this way you can store the front, and what you will do, you will simply, I have already said, you will simply reverse the arrow. How you will reverse the arrow? Temp next is equals to back. Okay, temp next is equals to back, and you will jump to the next, where my temp will be here and my back will be here. By this temp next will be back, and temp before that, temp next will be your front, and you will break this temp next equals to front, then you can break this and you can do temp next equals to back. Okay, this is the way how the linked list will be reversed. So I will write temp next equals to back, and back equals to temp, because I will move the back pointer also. Back is equals to temp, and temp is equals to front. Hope you have understood why I am writing this. Okay, I will again draw the linked list to make you a clear understanding. So this is my temp, this is my front, this is my back. Okay, so I have said that if you do this, which means temp next. Now temp next front is equals to temp next. Okay, now my front is equals to temp next. So if you reverse this, why I have to store this element? Because if you reverse this, then this link will be lost. I cannot access the rest of the link list. I cannot access. So I have to store that front also. So I have stored that front, and I have said that this temp next is equals to back. You have to visualize it, okay? Because in the broader concept, you cannot draw the whole link list. So what you will do simply temp next is equals to back, by which you can reverse the pointer. And what you will do next, you will move your temp here, you will move your back here. In the same way, suppose this will be your front. In the same way, temp next will be your back, where this connection was lost, and you will rebuild the connection. Temp next equals to back, and you will in the same way temp is equals to back, and front will be become temp. In the same way, the rest of the link list will continue. Okay, and what will be your fast back? Your fast back will be null. Why null? Because it was, at first it was your head. Now I have said that it have to point to null. Now before head, before that 4 was pointing to null. Now 1 will be pointing to null. So because of that, my back will start from here, and back will point to null. Okay, so my I will again draw the picture. Now sorry, this is my back, and it is pointing to null. Okay, and this is my temp, and it is also head. Okay, and this is my front. Okay, at first step, what I will do, I will do temp next is equals to back, which means temp next now pointing to null. Okay, and back will be updated as temp, same as temp will be updated as front. By this, the whole loop will be iterated. Now think one thing, I have to return this head. Okay, I have to return this head. So for that, what should I return? Should I return temp or should I return back? One thing you have to remember, temp will pointing to temp next. Okay, my front, when I am here, my front is here, means my front exceeds, my front is here, my back is here. Okay, my handwriting is not good, but you have to understand it. My temp is here, my front is here. After reversing my link list, what I have done, my back is here now, my temp is here now, which means my temp is pointing to null now, and my back is the last element of the link list. From this I can conclude that back is my last element of my link list. So after reversal, what I will return, I will return my back. Okay, I will return the back. So what will be the code of this? I have already said that I have to return the node. So my function will be reverse link list node star of head, this black pen, and I have already said I will initiate as null and initiate temp as head. So I have already said that my loop will continue till temp is not equals to null. Okay, now my node star front will be what? Temp next, because I don't want to lose the rest of the link list. So as my link will be destroyed. I know that after reversing, where I have done, I know that after reversing, I cannot find the, oh sorry, we know that after reversing I will lose this, lose the rest of the link list. Okay, after reversing, so I will store it. So node star front, and I will do temp next equals to back. I have already said, suppose temp is here, temp next will be your back. Okay, and now previous, sorry, I have already declared as back will be your temp. Okay, now back, after reversing, back will be your temp here, and now temp will be your front, and I will simply return the back. Why I have returned back? Because my back is giving the last element of the linked list. So hope you have understood the whole problem. Now I am going to submit the code and check if the code is running fine or not. So here is your code. I will submit it. Hope it will perfectly submitted without any error. Yes, all test cases passed. Thank you everyone.